Imagine this for a second. A really complex transplant surgery is happening, right? But the top expert, the one guiding the whole thing, they're thousands of miles away, maybe looking through a screen, maybe even using, like, augmented reality to show the local doctors exactly where to go next. Sounds like science fiction, doesn't it? But what if I told you it's been liking? Well, it's starting to happen. Today, we're doing a deep dive into something called tele-transplantation in resource-limited settings. We'll probably call them RLS as we go. This is a field that's moving really fast, trying to bring these incredibly complex, life-saving surgeries to places that really desperately need them. We've got a great source for this, a comprehensive review looking at different models, new innovations, even a sort of how-to guide for getting started. Our mission today: uncover the key insights, maybe some surprising facts about how technology can bridge this huge gap in healthcare access, specifically for organ transplants. And crucially, it's not just about doing surgery remotely. It's about enabling the local teams to do it themselves. That's the goal. My first thought is just, wow, how does something that complex like a transplant even begin to work across huge distances, especially, when resources are tight? Let's unpack this.
Yeah, it's a great question. And what's fascinating is that the picture you painted, that sort of sci-fi remote control surgery, while it is technically possible in very specific high-tech situations, that's actually not what teletransplantation usually looks like, or maybe even should look like in these resource-limited settings.
Okay.
So let's get that clear right off the bat. Pure remote-controlled robotic surgery for a full organ transplant. Still very much experimental, extremely rare. It gets the headlines, sure, it's technically amazing, but it's just not the practical reality for most places we're talking about.
Right, so the image of a surgeon in, say, London controlling a robot arm in Lagos, that's not the main focus for RLS right now.
Yeah.
But has there been a big moment that proves the concept, like a moon landing for remote surgery, even if it wasn't practical for these settings?
Absolutely. You're probably thinking of the Lindbergh operation back in 2001.
Yes.
A surgeon in France performed a gallbladder removal, a cholecystectomy on a patient in the U.S. Totally remote. It proved it could technically be done. But, and this is the key thing, it needed dedicated, super high-speed fiber optic lines. It cost a fortune.
Okay.
Completely unsuitable, unrealistic for resource-limited settings.
So if that's not it, what is the model that's actually feasible?
The dominant model, really the only broadly feasible one right now for RLS, is what we call tele-mentoring, or sometimes teleproctoring.
Tele-mentoring.
Yes, it's not about a robot doing the work. It's about an expert somewhere else providing real-time guidance, decision support, training, usually during the really tricky parts of the surgery or maybe managing care before or after. And it uses technology that's more available, decent broadband, standard video conferencing, things like Zoom or Skype.
Ah, okay. That makes a huge difference. It's like having an expert coach looking over your shoulder virtually.
Precisely. It's about knowledge transfer and support, not remote control.
So with that model in mind, are there real-world examples where this telementoring has made a difference in something as complex as, say, a kidney transplant?
Yes, definitely. There's a really good case study involving Aravind Eye Hospital in India. They have amazing infrastructure, by the way, and Guy's Hospital in the UK.
Okay.
The UK surgeons helped plan the procedure, and then, crucially, they provided live intraoperative guidance through a video link, while the Indian team performed a laparoscopic kidney removal from a donor and the actual transplant.
Wow, live guidance during the operation itself.
Yes, for the complex steps. And it was successful. It clearly showed you could do this high-level mentoring across continents for really intricate procedures.
That's incredible. But you mentioned Aravind had good infrastructure already.
That's a fair point. It highlights both the potential and a limitation you need some foundation to build on.
Right. And I guess it's not always about the transplant surgery itself. Maybe building up the skills needed before you even attempt a transplant.
Exactly right. Building foundational capacity is key. There's another great example. A collaboration between the University of North Carolina, UNC, and Kamuzu Central Hospital in Malawi. Here, U.S. surgeons mentored Malawian surgical teams, again, using standard video conferencing like Zoom or Skype for complex general surgeries, urology procedures, things like that.
So not transplants directly, but complex stuff.
Right. These weren't transplant operations, but the project successfully built up the local team's skills in advanced procedures, skills that are directly applicable if they were to start a transplant program. It really proved that even with lower bandwidth, this kind of mentoring for complex surgery is viable. It shows you can build capacity step by step.
That makes a lot of sense. Build the base first. So we've got surgical guidance, skill building. What about managing the patients outside the operating room? pre-op, post-op care, immunosuppression. That's a huge part of transplantation.
Absolutely vital. And there are models for that, too. Project ECHO is a big one.
Oh yeah, I've heard of ECHO, Extension for Community Healthcare Outcomes.
That's the one. Started in New Mexico, now it's global. It uses this hub-and-spoke virtual network idea. So for transplants, you might have a major transplant center, maybe in South Africa, maybe in India acting as the hub.
Okay.
And they hold regular virtual clinics, case discussions, using video conferencing with clinicians out in the spokes, the resource-limited settings.
So like virtual grand rounds, but focused on transplant issues.
Exactly. They cover patient selection, managing immunosuppression drugs, which is tricky, troubleshooting complications after surgery,
Yeah.
all that crucial stuff. It's not live surgery guidance, but it's absolutely essential for making a transplant program function. It builds the knowledge and confidence of the local doctors and nurses, reduces the need to send patients far away, too. It builds a whole ecosystem of care.
Okay, so these models, tele-mentoring for surgery, ECHO for wider care, they sound really promising. Empowering local teams seems like the right approach. But
Yeah.
you hear about these successes, yet tele-transplantation isn't everywhere in RLS. Why not? What are the big roadblocks?
Yes. The hurdles. And there are definitely significant ones. Let's talk tech first, although it's not always the biggest issue. Connectivity, for instance. Yes, 4G is expanding in cities in many RLS, and you can often get decent HD video for mentoring now. That's improving. But the kind of connection you need for pure telesurgery, that ultra-low latency, practically zero delay, that's just not widely available. And 5G, still very early days, very expensive where it exists at all.
Right. And the robots themselves.
Yeah, robotics. The big systems, like the Da Vinci robot, they are incredibly expensive, just financially out of reach for most RLS hospitals. And right now, there aren't really any affordable, tough, reliable robotic systems specifically designed for complex stuff like transplants in these kinds of challenging environments.
So the fancy robots are a non-starter for cost reasons.
Pretty much. Now, you can get good, affordable HD cameras, microphones, screens for the mentoring side of things. That part is feasible. But the high-end robotics, not yet.
Okay, so tech has limitations, especially latency and the cost of advanced robotics. But you hinted it's not just about the tech. What are the other big barriers? It sounds like a tangled mess.
It really is a complex web. And honestly, one of the surprising things you find is how often the non-technical barriers are the toughest ones to crack.
Like what?
Well, basic infrastructure, think about it. Unreliable electricity, power cuts right in the middle of something, internet that drops out constantly, not having trained technicians on hand if equipment fails.
Yeah, you can't mentor if the power's out.
Exactly. Then there's the simple cost. Not just the equipment, even the affordable stuff adds up, but connectivity costs money. And the expert's time giving them mentoring, that has a cost too. And maybe the most fundamental issue, the workforce. You need a trained local team on the ground first. Surgeons, yes, but also anesthetists, nurses specialized in transplant care, perfusionists, ICU staff. If that core team isn't there or isn't well trained enough, teleguidance can only do so much. You're building on sand.
So you need the people first.
You absolutely do. Then you layer on governance issues. Lack of standard rules and protocols for how to do this safely. Who's legally responsible if something goes wrong? The mentor miles away or the local surgeon? Cross-border licensing and credentialing is a nightmare.
Oh, I hadn't even thought about the legal side.
It's huge. And finally, there are real ethical questions. Does this technology accidentally make healthcare less equal by concentrating expertise in urban centers connected to the hubs, leaving rural areas further behind?
That's a serious concern.
And informed consent. How do you make sure a patient truly understands that their surgeon is being guided remotely, potentially by someone they'll never meet, from a different country? It's complex.
Wow. Okay, that's a lot of challenges. Infrastructure, cost, workforce, governance, ethics. It does sound daunting, like trying to build that rocket while it's taking off, as you said. But let's shift gears. This isn't just a story of challenges. Where's the hope? What are the innovations? What's on the horizon that could actually, be a game changer here?
Right, and this is where it gets really interesting, I think. The key principle driving innovation has to be make it affordable, make it robust and tough, make it simple to use, and critically, make sure it augments what the local team can do. It's about support, not replacement.
Okay, so affordability, robustness, simplicity, augmentation. What does that look like in practice?
Well, take robotics. Instead of trying to replicate the super complex Da Vinci, maybe focus on simpler, task-specific robot.
Task-specific,
Like maybe a robot arm just designed to do the really tricky blood vessel connections, the vascular anastomosis very precisely. Or exploring open-source robotic platforms using cheaper, off-the-shelf parts, modular systems you can adapt.
cheaper focus robots.
And
Makes sense. What about the connectivity problem?
that's absolutely critical. We're seeing ideas like edge computing or local AI.
Edge computing.
Yeah, basically doing some of the video processing locally at the RLS site before sending the data. Means you don't need as much bandwidth to send the important stuff to the mentor, like a smart filter. And things like delay-tolerant networking, DTN. It's designed for situations where the connection is patchy, intermittent. It basically makes sure the data packets get through eventually, even if there are delays, like a reliable postal service for data.
Okay.
And even optimizing satellite internet like Starlink, maybe with special medical quality service levels that prioritize surgical data to keep latency down.
So assuming we can get a decent connection, what about the tools the mentor and surgeon actually use? How can that experience be improved?
Great question. This is where advanced tele-mentoring tools come in. Think augmented reality AR.
AR, like wearing special glasses.
Exactly. The remote expert could draw annotations, like circles or arrows, that get overlaid directly onto the local surgeon's view through their headset, pointing things out right on the patient, virtually.
Wow, okay. That sounds powerful.
Or AI assistants within the operating room. Local AI tools that can identify anatomical structures, maybe alert the surgeon if they're deviating from a plan, or even suggest the next step based on the surgery's progress.
AI is a co-pilot for the surgeon.
Sort of, yeah. And compensating for the lack of touch haptics. Since the mentor isn't there physically, maybe using visual cues or sounds to give the local surgeon feedback about tissue tension or resistance.
Interesting. And outside the OR itself, any tech helping there?
Yes. Things like portable devices, maybe using AI to assess donated organs remotely to see if they're viable for transplants, better imaging on the go, and even using things like blockchain for securely tracking organs during transport, making sure they get where they need to go safely and transparently.
Okay, the tech is fascinating. But what about the human side? Training people, setting up the systems. How do we make these programs sustainable?
Absolutely crucial. Innovation is happening there too. Developing low-cost simulators using virtual reality or augmented reality combined with physical models so teams can practice safely.
Better training tools.
Yes, and maybe AI-driven learning platforms that adapt to individual trainee needs. Personalized surgical training. And on the system side, exploring new models for governance and funding. Maybe consortia of hospitals sharing the cost and expertise of a tele-transplant hub. Or financing based on successful patient outcomes, developing international agreements on liability to make collaboration easier.
Right. Sorting out those tricky legal and financial bits.
It all has to work together.
So bringing this all together, if a hospital or a region in a resource-limited setting wants to actually start doing this, what's the near-term practical playbook? What are the first steps?
Okay, the actionable steps. It has to be pragmatic step by step. Number one, build the local foundation, invest heavily in training those multidisciplinary teams we talked about, get the right people with the right basic skills first.
People first. Got it.
Then deploy simple telementoring. Don't wait for fancy robots. Use the broadband you have, get affordable cameras and screens, maybe link up with something like Project Echo for the broader care support. Start simple.
Use what's available.
Exactly. And be strategic. Target the high-impact steps. Focus the remote experts' time on the most difficult parts of the procedure where their guidance makes the biggest difference, like that tricky artery connection in a liver transplant. Maximize the value.
Smart allocation of resources.
Then, maybe pilot affordable tech. Partner with some of these innovators developing simpler robotics or AI tools. Test them out in your setting. See what works. And critically, establish clear protocols. Write down the rules for your specific context. How do you get consent? Who's liable? What's the backup plan if the internet fails mid-procedure? Data security. Get that sorted.
Essential groundwork.
And foster real partnerships, equitable partnerships between hospitals and high-income countries and LMICs focused on genuinely transferring skills and capacity for the long term, not creating dependency.
True partnership.
Finally, advocate for better infrastructure. Work with governments, telecom companies to improve power reliability, get better internet access specifically for medical needs. That underpins everything.
It's a multi-pronged approach then. Tech, people, protocols, partnerships, infrastructure. If we pull back and look at the big picture here, it feels like the core message isn't really about the flashy technology, is it? It's about empowerment.
That's exactly it.
The future of teletransplantation in RLS isn't trying to copy what happens in a high-tech U.S. hospital. It's about using technology intelligently to boost what local teams can already do or learn to do.
Precisely. Telementoring is what's possible now. It's actionable. And those innovations we talked about, the simpler robots, the AI, the AR, they offer real pathways to expand that capability in the future.
So success really comes down to putting local empowerment first, finding sustainable ways to pay for it, and taking those practical step-by-step actions to overcome the biggest bottlenecks holding back transplant access.
Yes. The ultimate aim, like we said at the start, has to be enabling local teams to perform transplants safely and effectively themselves, not just having transplants done by remote control. And when you hear about successes like that India-UK collaboration, it reminds you why it matters. It's unlocking human potential, local potential, using technology as a tool.
That's a really powerful way to frame it, empowering local potential.
Yeah.
It does leave us with a final thought to chew on, though. As this technology expands, what are the ethical wrinkles, the unforeseen societal effects, especially around how medical expertise flows and how patient expectations might change when you have these vast differences in resources between the mentor's location and the patient's?
That's a deep question. The equity implications, the potential for new disparities, are definitely something we need to keep a close eye on.
Indeed. Something for you, the listener, to mull over.
Yeah.
What happens when expertise can cross borders so easily, but resources can't? We'll leave you with that thought until our next deep dive.